Welcome to the 7th meeting of Cryptography Club. Today we're going to be talking about advanced encryption, decryption review, and this is also the last meeting of Cipher. So for advanced encryption, we want to make the encryption even harder to decrypt because earlier we were just moving the letters a few places in the alphabet. So for example, if there was one letter word or a two-letter word, then it is very obvious what those words might be. So if it was a one-letter word, it could only be I or a, and that would be very easy to decrypt. So we're going to talk about some ideas of more advanced encryption using Caesar cipher. So I'm gonna give a few ideas at the end, but this is the idea that I'm gonna give a code for. So it's encrypting like usual, but removing all the spaces, punctuation, and special characters. This makes it harder to decrypt because we don't know where the words are, and it's harder to manually decrypt. So here's the code for it. It is basically the same thing as before, except in the function where we encrypt the characters. Over here, it used to be giving char, which is the character we want to encrypt, to new char, which makes it appear as the same thing in the ciphertext. But over here, right now, it says if it's not capital letters or lowercase letters, so in this else, it's going to contain all of the spaces, punctuation, and special characters. We make the new char that we're going to return an empty string. So this will return an empty string, and if we print it, it's not going to appear as anything. So it's going to be the same thing as basically deleting that character. And then for the rest of the code, it's the same as before. We take the plaintext.txt, which is the plaintext, we read it and give an offset over here. This is 2601 right now. And then in the loop, we encrypt it using the function we define up here. And then we print the original plaintext and then print the new ciphertext and close the document. After we finish with the plaintext and generate ciphertext, we open the ciphertext.txt in write mode and put our ciphertext into it. Lastly, we close the document. So let's see how this code works. Here in my folder, I have the encryption file and my plaintext in this document. So we can see that it has all the spaces and special characters right now. So in here, we want to preserve this number, so we turned it into the letters instead of numbers. And then right now, the ciphertext.txt is empty, but after we run it, it's going to have the ciphertext in it. So let's run it now. This was our original plaintext, and then it generated the ciphertext, which is also in the document now. Now let's review some of the decryption. We're going to be using the same decryption code as before, and the decryption process does not change because it is still possible to find the appropriate plaintext from all the plaintext possibilities. So the logic that we're using here is because it's the Caesar cipher, we can decrypt it by encrypting it again with the offsets from 1 to 25 because there are only 25 letters in the alphabet. So if we encrypt it using the offsets from 1 to 25, and then look at all of the possible plaintexts, then we can find the appropriate one that is readable, and then use that as our plaintext that we find again. So here's the decryption code. It's the same as before. This function is the encrypting function, and here we can see that we have character giving it to new character. So this means that if it's a character that's not a capital or lowercase letter, then it doesn't change. And then so if it's a capital letter, we encrypt it according to the offset, which is n, and then we also mod n with 26 to figure out which number it is according to 1 to 25. And we do that and we do the same thing to that with lowercase letters, and for everything else it remains the same. And then the other part is taking the ciphertext, reading it, and then here is a loop. So it loops from 1 to 25 because 26 isn't included. And then so that's the offset. Every time the offset changes. So the first time the offset is going to be 1, and then we encrypt the ciphertext again with the offset of 1. We print the offset, which is going to be 1 in this case, and print the new string, which is the generated plaintext possibility. Then we print something empty, which is just changing the line or skipping the line. And then after we print this, we go back to the front of the loop and it turns into 2. So it's gonna encrypt the ciphertext again with the offset of 2. And this process repeats until it reaches 25. After 25, after it prints the offset for 25 and the ciphertext for 25, it closes the ciphertext document. And then it's gonna give us a chance to input our offset that we think is the best. So we're gonna look at all of the generated possibilities of the plaintext and find the one that is the best, and we input it to here. It's gonna take this number, use it as the new offset that we know is the right one, and then generate the plaintext again. Lastly, it's gonna print the plaintext. After we have determined the plaintext, we take the plaintext created file in write mode and write our plaintext into it, and then we close the document. And it's also gonna print plaintext file was created, but it's cut off right now because of the screen recording. So here's the code. This was the line that was cut off, by the way. It's just gonna print plaintext file was created. So right now let's look at the folder. This is the Python file, and we have two other text documents. One is the ciphertext, which is currently empty, and a plaintext created, which is also empty. So we want to put our ciphertext into the ciphertext document. The ciphertext is the one we generated over here. So if we're actually doing this in real life, the ciphertext, it would be the document that we share to the other person, and it's the only document that is ever shared. So if I'm the other person now and I receive this ciphertext, I'm gonna do this process of decrypting it to find the plaintext. So now I'm gonna run the file. It gives us all the possibilities, and we can look through each one of them. So we look at the first one, we see all this mixed up jumble of letters, and it doesn't make any sense. The same with the second one. It's another jumble, but it's different from the first one. And the third one is not good either, like the first two. The fourth one is not good either. The fifth one is not good either. And because each time the offset is changing by 1, we can see by the first letter that the first time it's an R, if the second time it turns into an S, and the third time it turns into a T, the fourth time it turns into a U. And this makes a lot of sense because we're just encrypting it with offset that is changing by 1 each time. And then we look through all of them. 7, 8, 9, 10. These all don't make any sense to me. And these don't make sense either. Until we get to offset 25, we can see that there's some words in here. And we can even read it, like, possibly the most important code-breaking event of the war was the successful decryption by the Allies of the German Enigma cipher. So we know that this is the right one, and this is the plaintext that we're looking for. So in order to save the plaintext into a file, we tell the Python program what the good offset is. So we put 25. It generates the plaintext again and puts the plaintext into the plaintext file. So now the plaintext is in the file, and we can use this file if we want to work with other people and share it to them, or just make modifications easier. So that's all for the encryption and decryption part. Let's look at some of the other ways we can use advanced encryption. So some other, because removing all spaces and special characters is not the only way to make a stronger ciphertext. Here I've made 3 other ideas, but there's way more ideas that people can think of. So these are just the 3 I thought of. The first one is swapping every 2 letters, every 3 letters, every 4 letters, etc. For example, we have the plaintext, the quick brown fox. If we swap every 2 letters, H and T will be swapped, Q and E will be swapped, I and U will be swapped, etc. So this way, it would be easier, or it would be harder to find the plaintext from the ciphertext, because the person that's trying to decrypt it doesn't know what method we're using to encrypt it. So if they just use our decryption method that we've been using the whole time, like changing the offset from 1 to 25, then they're not going to find a plaintext that makes any sense. The second idea is flipping the whole plaintext. So we put the letters at the front to the letters at the back, and the letters at the back to the front. So in this example, T used to be first, now it's last. H used to be second, now it's second last, and X used to be last, now it's first. And this basically is like making it mirroring it and making it harder to decrypt. The third one is both shifting and swapping the letters. So we're combining number 1 and number 2. So if we have this, possibly the most important code-breaking event, and first we encrypt it with an offset of 1, P becomes Q, O becomes P, S becomes T, and all the way to T, becoming U. This is our encryption with shifting, and then to make it even stronger, we want to swap it. So we're swapping every 2 letters in this instance. So P and Q get swapped, T and T get swapped, J and C get swapped, all the way to O and U getting swapped to F and U. Oh wait, never mind. The U doesn't get swapped because there's an odd number of letters here. So the F and the O get swapped here, like O and F, but the U doesn't have anything else to swap it with, so it just ends up here. And so the way to think of it is basically like the letters are a deck of cards and you can shuffle it in any way, but if you let anyone else know how you're shuffling it, or you shuffle it in a really simple way, then it's really easy to find out what the original order was. And there's a lot of ways to shuffle it to make it harder to decrypt. That's it for today's meeting. Thank you for watching. Next meeting, we're gonna start talking about RSA and get into more exciting stuff. I hope you liked the Caesar cipher.